Hello, my name is Danial Agha, and this is my COM624 machine learning demonstration of my financial stock analysis software artifact solution. Quickly, when it comes to my software artifact solution, it contains two files. The main.py file, which holds all the main code that I've written, the machine learning models that I've created and utilized, and also libraries that I've utilized to essentially complete all the 7 tasks that have been set out in the assessment brief. Alongside that, I've got another file called the Streamlit GUI.py file, which is essentially a GUI that allows the user to interact with my application, and it imports the main.py file and is also used to essentially communicate with the main.py file to call functions within the main.py, depending on what stock analysis they want to do. So I've utilized PyCharm to write this application, and I've also utilized Git to do version control so I can showcase the incremental changes. Alongside that, I have it stored on a public GitHub repository, which is this one here, as you can see. And we can also view all the commits that I've made and the incremental changes that I've made from task 1 to essentially tasks to completing task 7, where we're feature complete. For the first task that was set out in this assessment brief for this module is to retrieve the specific data that we will utilize for the stock analysis, for the financial stock analysis. For this, the required specific data that we need is the NASDAQ 100 companies data. So this is how I retrieve it within this code. So essentially, I have a list called tickers, which has the NASDAQ 100 companies stored in a list. I'll then set some date variables up, which is a 1-year time frame, and I have a data frame which I store it in. I then essentially go through all the I do a for loop with tickers within tickers, so go through this whole list and essentially download the adjusted close prices for each of the stocks within the NASDAQ 100 companies with this date variable, which is the 1-year time frame. To showcase the rest of the task implementation, I'm going to showcase this through my GUI application. So if we go to the terminal, we can run my GUI application by typing in the command streamlit, run streamlit GUI.py, hit enter, and it will run this application on localhost 8501. Excellent. My application has launched successfully. As you can see, this is the front page of my application. And an important information is to keep the data consistent for my solution, and due to stocks delisting errors, I've decided to stop the data retrieval on the 26th of December 2023. Bear in mind that I am still retrieving a 1-year worth of stock data that I am analyzing with my solution. This is a great opportunity to showcase my solution in analyzing data and the predictions with real-world data. For task 2, as stated in the assessment brief, is to apply grouping. Apply clustering to group the 100 NASDAQ indexes companies into 4 groups. This task was sort of split up into 2 subtasks. The first task was to use a dimensionally reduction algorithm, such as PCA, to reduce the 250 columns that was within my dataset to around 10 columns. The second subtask was to use any clustering algorithm to group the stocks together into 4 individual clusters. To visualize this, we will go to my application as it's been successfully launched. We'll head over to the navigation page and we'll go to the PCA k-means. As you can see, the first subtask was the dimensional reduction utilizing PCA. As you can see, within this code snippet, we verify the shape before PCA reduction to verify the shape of the data. As you can see, 100 rows and 250 columns. The 100 rows represent the 100 NASDAQ companies. I then utilize this code snippet here to perform PCA reduction within the code snippet to reduce the columns from 250 to 10 columns. After the PCA reduction, I then use the code snippet below to confirm and verify that the PCA reduction has been successful. And this is the output that I get, 100 rows symbolizing the NASDAQ companies, and then now the 10 reduced PCA columns. As you can see, this is just the raw data output as well. So this was just output in the shape, and this is just output in the data. As you can see, the 10 PCA columns with their tickers associated with it. The second task was to utilize clustering with k-means. To group the stocks together into 4 separate groups, I utilized a clustering algorithm, k-means, to group the stocks together into 4 separate cluster groups. The snippet below shows how I've utilized k-means clustering to group the stocks into 4 separate groups. As you can see, we call it a variable k-means, and we call the k-means, we instantiate a k-means with 4 clusters, and then we instantiate with 4 clusters. We then have the cluster labels, and then below are the cluster groups and what their stocks belong to, which cluster groups. As you can see, cluster group 0 has the majority with 74 clusters. Cluster group 1 is the anomaly with just the 1 cluster group. 2 has 20 clusters, and cluster group 3 has 5. From these 4 cluster groups, I would then select one of each group. For the code implementation, here it is. As you can see, this is the function. Here is the PCA reduction stuff. Most of the majority of the code is just output stuff. And then this bit is the clustering. The k-means clustering. And just I've created some lists and append them to these lists just for better visibility, so it looks a bit more better visible when we output it onto our GUI application. And that's it for task 2. For task 3, as stated in the requirements brief, is to present the top 10 highly correlated positive and negative for my 4 selected stocks against the whole dataset. If we go to my application and navigate to the correlation analysis page, we can see the correlation analysis page. Here we have a correlation index heat map for each of my selected stocks with their top 10 positives and their top 10 negatives alongside it. Alongside that, so we have the top 10 positives for one of my stocks, NVIDIA. As you can see, the correlation index heat map for that. And we also have the raw data as well. So we have 2 visual stances, the raw data and the correlation heat map. We have the top 10 positive for NVIDIA, top 10 negative for NVIDIA again. So that's that one there. Positives and negatives for AMD, for BKNG, and also their raw data as well that you can expand. And top 10 positives for ORLY and their negatives. And if we go to the code implementation, we can see that we get the selected stocks correlation. We also get the whole data's correlation, and we utilize this function here to compare, and we also output it on the correlation heat map as well. This is the positive side of things, and this is the negatives. But the requirements set in the assessment brief for task 4 is to perform exploratory data analysis for each of my selected stocks. If we navigate over to the EDA visual analysis page, we can see that there's a time series analysis of my selected stocks. As you can see, this is a time series plot of the adjusted close prices for my selected stocks. Here we can see that BKNG is one of the outliers with a far superior adjusted close price compared to my other selected stocks. Another EDA that I've created and performed is the correlation matrix heat map between my selected stocks. Here we can see the positive correlation between my selected stocks. Here is the code implementation for this. As you can see, this is the correlation matrix heat map code, and this is the time series plots for my selected stocks as well. For task 5, stated in the assessment brief, is machine learning models for prediction and forecasting. Propose at least 4 machine learning models and train it over each of the stock data to predict and forecast the price action. Then critically analyze and compare all 4 models. So if we move over to the machine learning models and prediction page, the first model that we're going to look at is the ARIMA model. So if we run the ARIMA model, and there you go. Here is the ARIMA model. Here's the performance metrics for the ARIMA model. And here's the 7-day forecast. As you can see, the prediction with the real stock data is actually quite good. But unfortunately, when we try and do a 7-day forecast for it, it doesn't fade to be the greatest. As you can see with AMD and BKNG and ORLY. There's a little bit of a change in BKNG, but not really the greatest. And here is the code implementation for ARIMA. And we build the multiple forecasts within the ARIMA model, and then we plot it, and then we provide it the performance. As you can see, these are the plotting of the results first, and then the forecasted predicted price as well. Right, the next machine learning model that we're going to have a look at is the LSTM model. So if we run the LSTM model, as you can see, we can showcase the epochs training, which is 50 epochs iteration. So what can we see? We've got this first graph, which is the validation loss for stock. So it's just basically comparing the train and test graphs. We also see a plotting predictions with real historical data for our stock, NVIDIA. And we see a zoomed in section of this bit here, which is the prediction versus training data for the stock NVIDIA. As you can see, it's not really that close and it's not very accurate when it comes to LSTM. So it's not really the best, but against the real historic data, I think ARIMA is also a better model than this one, but this is a better model for prediction, I'd say. Implementation. So here's the data set that we play with, the LSTM model, visualizing the validation loss, and the two prediction graphs that are in here within this LSTM function that I've created. The next model that we're going to have a look at is the linear regression model. So if we run linear regression, as you can see, with the linear regression model, it's only good if the data is quite linear. Now, and it's not very good when it comes to having a lot of variance within its data. As you can see, if there's outliers, the linear prediction doesn't really go so well. Especially with, for example, ORLY. As you can see, there's quite a lot of variance. I wouldn't really recommend using linear regression for this sort of instance, since it's 1 year data. I think it would be a really good solution to use linear regression in small data where there's not really a lot of variance. So if there was like 7-day data, would probably be better, not 365 days, since there's a lot more variance within linear regression. And for linear regression, here is the code implementation. So as you can see, we have the linear regression model that we made, and we visualized the linear plots. Well, the prediction from linear regression. Next machine model, and the one that I think is the best, is the FP profit model. As you can see, it is a very close prediction to the actual real stock data. The actual price are these black dots, and the prediction that it makes is within this blue line here. And I find it very close compared to the other models. We are running the FP profit forecasting for 365 days. We can also showcase the raw data here. So as you can see, it has, if we scroll all the way down to the bottom, it will have the 365 days as well. I think this is the best model, and we will utilize that within task 6 to provide market analysis for that as well. And if we showcase the code implementation, there it is, FP profit. This is the model section here, and then we plot the prediction with it as well. But task 6, as requested in the assessment brief, is to provide general trading and signal analysis. I critically analyzed all the 4 models that I utilized within Task 5, to determine which is the best model to be used for the prediction and forecasting. For me, I decided to choose the FB Profit. So if we move over to the general trading signal and analysis, ignore this minor error here, it's just a warning. So if we put a stock in there, like Tesla, and then we choose the stock, the analysis duration, we'll pick 14 days. And for example, here it is. So it will analyze and forecast the stock prices for the next 14 days. As you can see, we have the predicted next 14 days. We have the latest up-to-date stock date, which is 22, which is posted, and the stock price on that. We also provide the raw data of the next 14 days. And we also give some analysis, saying I advise you to invest in the stock because the stock price will increase in the next 14 days. If we move over and choose a different one, like for example CTAS, and we change the variance to 7, and we analyze that, we can see that with the prediction, it's getting lower. It's giving us the latest stock information, and it's also advising us not to invest in the stock at all because the stock price at the moment is $5.95, and in 7 days it will reduce in 7 days. The final task, which is requested in the brief, is to provide a GUI which allows the user to be able to perform EDA, correlation prediction, forecasting, and binary signal analysis. As you can see on the left-hand side with the navigational panel and the demonstration that I provided, that you're able to do these functionalities within my application. One limitation of my application is that within Streamlit is that when running some of these machine learning models is that there's sometimes a caching issue. Some of these models do not work effectively within Streamlit. So I had to implement this button which stops the model and allows me to work on another one without any caching issues. When I was running these models within my terminal locally, there was no caching issue whatsoever, but with Streamlit there is some slight issues. These issues were never cropped up whilst in my demonstration, but sometimes they can happen from time to time. These are not issues with my model implementation as I know of. It's more issues with Streamlit handling the caching. Another limitation is that I'm not able to have the up-to-date data. This is why I had to cut it off. I know that I've stated that it is a great opportunity to showcase my solution in analyzing data with real-world data, but due to the PCA and K-means having issues with up-to-date data where sometimes if you had up-to-date data, some of the stocks will be delisting, and the PCA K-means was just not simply working. So at this moment of time, I've stuck it to halt the data retrieval. But when it comes to task 5 and 6 for market analysis, I can simply just change this to today, and it would simply work with no issues whatsoever. But sometimes PCA and K-means doesn't work if one of the stocks have been delisted. Finally, in the future, I would like to look to utilizing Streamlit Cloud Community and deploy this application instead of running this on localhost 8501. This is something I'll probably look into the future outside of this project timeline. Thank you for listening to my demonstration, and I hope you enjoyed it.